Okay, so now that we know how to simplify, we can multiply and divide. So let's review how to multiply fractions. So if I have two fractions and I multiply them together, all I do is multiply the numerators together, top, top, and multiply the denominators together, bottom, bottom, and 77. And then you ask yourself, can I reduce that? So here, there's nothing you can divide both of these by, because if you look over here, there's nothing that they had in common. There's nothing I could cancel out. So in this case, that's all we would do. Right? So when you're multiplying fractions, you multiply numerators together and denominators together. Right? What if the second one's a whole number, or either one's a whole number? Then first you got to make it to a fraction by putting it over 1, and then you can multiply numerators and denominators. So numerators, negative 3 and 5 is negative 15. Denominators, 2 and 1 is just 2. So again, can I reduce it? Nope, so it just stays negative 15 over 2. And actually that negative sign you'll see in the very front. That's the same thing as saying negative 15 over 2. As long as one of them's negative. If both of them are negative, then it's positive. But if one of them's negative, the negative can come up to the front. Okay, last one. Top, top gives us 24. Bottom, bottom gives us 15. Now this time we can reduce. So what number can we reduce both of these by? Well, 24 is 3 times 8. And 15 is 3 times 5. So they both can be reduced by 3's. So we're left with 8 over 5. So we're going to have to do the same thing we did last time with reducing. When we're multiplying and dividing, we multiply and divide first, and then we reduce if possible. Okay, so here, top, top gives us these 3 in the top, a times x times c. All the denominators, bottom, bottom, gives us b, d, and x. So since we're multiplying, we have x on the top and the bottom. We can cancel it out. And we're left with AC over BD. So again, you can only do that if it's multiplying. If it's adding or subtracting, you cannot cancel it out. Okay. So now we're actually dividing these. You're going to refer to your warm-up. Well, not for the first one here, but for the x's, I'm not going to work out all the x's because you've already done that part. But we won't need it here because this one's already factored for us. But on the other ones, I'll set up some x's. But like I said, you've already done it, so you can just look at your practice problems. Okay, so we're multiplying these two things together. When we multiply, first we factor. Notice these are already factored. Actually, I'm going to put this in parentheses so that it looks like a factor. All I do is combine everything in the numerator together, all the tops. So 2, x minus 5, x plus 3, and then x plus 4. So all the tops, top times top, and all the bottom parts together. 3x, or x minus 3, x plus 4, x plus 3, x plus 2, all in the bottom. So now we have one big fraction. What I end up doing to cheat when it's a multiply, I just kind of extend it so I don't have to rewrite it off again. That's what I'm going to do for the other examples, but this is what it's going to look like. Before we start canceling stuff out, the excluded values are what x cannot be. So the opposites of the denominators, the zeros of the denominators. So the opposite of this one would be a positive 3. Opposite of this one would be a negative 4. Opposite of this one is a negative 3. And opposite of this one is a negative 2. So again, we can't divide by 0, so we gotta restrict all the values that make the denominator 0. Okay, so now we can start canceling. Let's see. We got an x plus 3 and an x plus 3, x plus 4 and an x plus 4. Anything else? So this 2 and this 2 don't cancel out. This is just a constant of 2. This is a factor, or a binomial of 2. So those actually stay. So the final answer here is 2 times x minus 5 in the numerator, that's what's left there. And then in the denominator, x minus 3. And the x plus 2 over here. So there would be your final reduced form. So again, it's like we did last time with the simplifying, but now we're adding multiply first and then reduce, then cancel them out. Okay, so we have a couple more examples like that, where we have to factor first. We have to use the x to put it in factored form. So again, I'll review the x for this one, but this one, they're all on your practice page, so you can just look at that. All right, so coming over here. So what I'm going to do when it's multiplying, I know I look at everything in the top and everything in the bottom together. So I'm just going to come over here and write one big fraction. So for this part, that's already factored. 2x stays there, x plus 2. For the second one, we're going to have to set up an x for this one. So we have positive 18 to get negative 9. So 18, 1 and 18, 2 and 9, 3 and 6. For it to be a negative 9 and a positive 18, these got to be the same. We want them both to be negatives. So which one gives me negative 9, negative 3, and negative 6? So then this part over here, this numerator, is x minus 3, x minus 6. And denominator, same thing. For this one, we want to make an x for this one. So negative 12 here, and a minus 4. Negative 12, 1 and 12, 2 and 6, 3 and 4. To make a negative, I know one's got to be positive negative. The bigger one is the negative one. So which one's going to give me negative 4, positive 2, and negative 6? This one is x plus 2, x minus 6. And then over here, I have this little 2x that just stays 2x. Okay, so what can x not be? For this one, right over here, x cannot be. Opposite of this is negative 2. Opposite of this is 6. This one is just an x by itself. So again, I want to know what's going to make this 0. When is 2x equal to 0? Solving for x. Divide by 2. 0 divided by 2 is just 0. So then that's this one over here. So again, all you're doing is making it equal to 0 and solving. But for these, it's just the opposite. When it's by itself, it's just 0. Okay, so now you cancel. 2x and 2x. X plus 2 and x plus 2. X minus 6 and x minus 6. So out of all of this, the only thing that's left is x minus 3. So that would be your final answer for this one. Everything in the denominator cancels, so technically there's a 1 down there. But when it's in the bottom, you really don't need it. If it's in the top, you need it. Not if it's in the bottom. Okay, and then we got one more dividing or multiplying example. one big fraction. We're multiplying. So I'm going to factor each of these. I'm not going to be able to make all the x's. I'll make a couple. But the other ones, you can just look at your notes. So here, set up an x for this one, negative 16 to get negative 6. So we have 1 and 16, 2 and 8, 4 and 4. Negative, I need the bigger one to be negatives. So which one's going to give me negative 6? Positive 2 and negative 8. So for the numerator here, this factors into x plus 2, x minus 8. This one is not a quadratic, so this one is actually just going to stay x minus 8. Only if it's a squared do you do anything. Not a squared, just leave it alone, unless there's a GCF. Okay, what about the denominator here? 64 to get negative 16. Now 64 has a lot of factors. Just look at your page that you've already done and see which ones give you 64. Well, I know 8 and 8 give me 64. But to make a negative 16, I need these both to be negatives. So here, this one factors into x minus 8, x minus 8. And I do the same thing for this one here. So make a little x for that one. Positive 6 to get 5. So this one's going to be 6 is 1 and 6 or 2 and 3. To make 5, I want the 2 and the 3. So positive 2, positive 3. So this one factors into x plus 2, x plus 3. So again, before we start canceling out, let's say what it cannot be. X cannot be. For both of these, it's the same thing. So I just got to write it once. Positive 8. That's the opposite of both of them. For this one, a negative 2. For this one, a negative 3. So now we can start canceling. Let's see. Plus 2, x minus 8, x minus 8, x minus 8, x minus 8. So everything in the top cancels. When everything cancels, I'm left with the 1 here. This time I do need the 1 because it's in the numerator. In the bottom you don't need it because dividing by 1 is the same thing. But this time we need it. So my final answer is 1 over x plus 3. It's my reduced form after I cancel everything out. Okay, so that's multiplying. Dividing's the same thing, except you multiply by the reciprocal. So you're going to multiply, but first you got to flip it around.